All right, this is for Michael. Hi, Michael. This is the second half of notes for 9-2. And we're going to start by, you guys have a stapled page, right? Yes. We're going to go to the back side of the stapled page. You got lots of room down here. And I'm going to do an example here to kind of like refresh our brains what we did yesterday. And then I'm going to talk about what is new today. Okay, so let's start with this example. Put this on the back side. Put 50 degrees. And we're going to graph him and we're going to find coterminal angles. Reese Payne, this is not optional. Put your phone away. Do it.
I don't have my phone.
I don't care. Then you're not writing. Okay. 50 degrees. What quadrant are we in?
The first.
The first quadrant, right? Rotating around, like 90 degrees would be here. Here would be 180, right?
Yep.
What's the bottom one?
270.
270 degrees, and then one full circle would be 360 degrees. So if I'm just doing 50 degrees, I'm still just in the first quadrant. Like that's, you know, am I more than half or less than half? More, right? 45 degrees would be just like exactly 45 degrees, right? So 50 degrees is a little bit more than that. This is 50, okay? 50 degrees. This is what he looks like in standard position. Don't forget when you're graphing it that you need to put your bottom side of your angle there as well, right? I have a lot of you guys that are graphing that are forgetting this line. I get that you can't really see it when you graph, but still try to put it over with pencil. Yes, Isaac, you did that yesterday, okay? Make sure you put that line down, okay? All right, now we're going to talk about coterminal angles again. Do you remember what the word coterminal meant? Same stopping place. Same stop, right? Same stopping place. So 50 degrees is from here to here, like rotating counterclockwise. If I decide, though, to rotate this direction, how many degrees would I go that way? That would be negative 310. And I get that by doing 50 minus 300, or 360. Sorry, 360. 50 minus 360 is negative 310. That will give me a coterminal angle. They're stopping at the same place. Okay, now instead of doing that, let's pretend or see I want to go around more than one circle, right? That would be like taking 50 and adding 360 to it, right? How many is that going to be? 410 degrees, right? And then I could go around again. I could add another 360 to it, right? Which would be like another cinnamon roll around, right? Adding 360 to that would be 770 degrees. All of these are, I could go on and on and on forever and ever and ever. And those are all coterminal angles. They're stopping at the same place, right? Okay, now, that's what we did yesterday. Coterminal angles, graphing them in standard position, that type of thing, okay? Now, down over here in this bottom corner, we're going to talk about degrees versus radians. Okay, I'm going to give you a little diagram, and then we'll go to the actual examples on the notes, okay? Degrees versus radians. We know from yesterday that if we're doing standard position, 0 degrees is here. 90 degrees is up here. We just mapped these out. 180 is here. What's the bottom one again?
270.
270. And if I go back to the original, that would be 360 again. FYI, or you answer this question, 0 and 360 are also coterminal, right? They're stopping at the same place, right? 0 and 360 are also coterminal. What?
He's in weights.
Just wait till the end and you can go find him. 0 and 360 are coterminal. All right. Now, these are all in degrees. And I said degrees is kind of like inches and radians is kind of like centimeters. We're measuring the same thing using two different units, basically. Okay? So let me explain to you what degrees and radians are. All right? We know degrees. Degrees are good. We know that. Radians have to do with kind of like a circle. So slap a circle onto your coordinate plane there. And what we're going to do is we're going to talk about like slices of pizza, okay, in this circle. So we just had stuff like 50 degrees, right? Like 50 degrees was a little over half of a one quadrant, right? 50 degrees is there, okay? That's in degrees. That's what I know. I know that those things. Radians are talking more specifically about like the crust of the pizza. So a radian kind of refers to the length of the crust of a pizza. Like, yeah, it's going 50 degrees, but how long is that? How many units is that? Okay? So what we're going to do is we're going to talk about radians in terms of a pie crust. The crust all the way around is kind of like finding the circumference. Circumference is distance around the circle, right? That's what circumference is. So if we're talking about pie crust, we're talking about circumference, right? So circumference of a circle, do you guys know what that is?
Yeah.
Like the formula for it is? What's the formula for circumference of a circle?
Is times pi.
2 times pi times r, okay? I have a lot of people get that confused with pi r squared. Do you know what pi r squared is? Area, because area is squared, right? I tell my geometry kids that all the time. Area is squared. So pi r squared is not circumference, it's area. Squared is area, okay? So circumference is 2 pi r. And for right now, we're only in this section going to be worrying about the radius being 1 unit. Okay, so if the radius is 1 unit, then the circumference is just going to be 2 times pi times 1, or just 2 pi, which means all the way around the circle. This all the way around the circle is a distance of 2 pi. Okay? What is a distance of 2 pi in terms of degrees? 360. So, 360 degrees is equal to 2 pi radians, right? 0 degrees would just be 0 radians. That's kind of unexciting, okay? But 2 pi is the same thing as 360. 2 pi radians is equivalent to 360 degrees. Kind of like there's 2.54 centimeters in an inch, right? It's just like the conversion. 2 pi radians is 360. Okay, now let's go ahead and fill all the other stuff in. If 2 pi is 360, what would be 180? 1 pi, right? That's half of it. 1 pi would be where 180 degrees is. Okay, now. What? Where? What did you say?
I said 1.5 pi.
Where would 1.5 pi be?
270.
270 would be 1.5 pi, he says. Okay, 1 and 1/2 pi. They're not going to write it as 1 and 1/2 pi, though. You know how they're going to write it?
1.5 pi.
What's 1 and 1/2 as an improper fraction?
Oh, 3/2.
They're going to write it as 3/2 pi, but they're still not going to write it as 3/2 pi. They're going to write it as 3 pi over 2. They lump the pi on the top. But essentially, that's 1 and 1/2 pi, right? 1.5 pi is like 3/4 of a circle, right? And then the top, 90 degrees, is a half of a pi, but they won't write it as half of a pi. They'll write it as
1 pi over 2.
pi over 2, yeah, or 1 pi over 2. Those are the radian conversions for each one of these. Pi radians, pi over 2 radians. Those are radians versus degrees. Does this make sense? Yeah?
Hang on.
Okay.
Top one
I'll
is
stop.
1 pi over 2.
1 pi over 2, or just pi over 2. Okay? What? Whatever. It's just the way that works. Okay? Now, radians are used a lot when we're finding, like, length of crest, right? Like, planets take, like, not circular orbits, but they're, like, elliptical orbits. But it's kind of the same concept. So if they're trying to find distance that a planet travels in an elliptical arch, like between this time and this time of the year, they're finding like the pie crust right here. They're trying to find the distance that is. So they can use radians to do that, okay? Anyway, let's go back to the notes. So we are on example 4, and we're running to convert between radians and degrees, okay? So A, what are they giving me? Negative 30 degrees. They're giving me a degree, and they want me to convert it to a radian. Okay, so we're going to convert. Now, here's the deal. We just said that 360 degrees is equivalent to how much? 2 pi radians, because it's from the circumference formula. So, how much would 180 degrees be? What did we say? This is example 4. How much is 180 degrees? Just 1 pi, okay? So here's how you convert from one to the other. Ready?
Hang on, no.
Let's do. What's your question?
Negative 30, which one would that be in for the things? Would that be?
Which quadrant would it be in? The fourth quadrant.
Okay.
Like positive 30 degrees would rotate up this way just 30 degrees. Negative 30 degrees would just be down 30 degrees. Good question. So this is in the fourth quadrant. Yeah. Okay, the conversion to go from radians to degrees is 180 degrees over pi, or pi over 180 degrees. Okay? and you use one versus the other depending on whether you're going from degrees to radians or from radians to degrees, and I'll show you which one you use. Okay, you just have to make a decision, but it's either pi over 180 or 180 over pi. Okay, now are you guys used to doing unit conversions? Have you done them before? If you've taken Mr. Moose class, he calls them train tracks. Do you know what I'm talking about? Yeah. So let's just do something really easy. I'll just like get your brain started here. Okay, you don't have to write this down if you don't want to, but you can. Let's say we're going 3 feet to inches. I always make it into a fraction. I put it over 1. You guys can figure this out probably mentally in your head, but 3 feet to inches. Here is how we convert. Ready? Times. This is called a unit multiplier, or Mr. Moose calls them train tracks. Okay? We have feet on the top here, so we want feet on the bottom so that they can cancel with each other. And I'm going to put inches on the top. Then I have to convert. So there are 12 inches in 1 foot. 12 inches, 1 foot. Make sense? And then my feet cancel out. So all I do is multiply the top. So I have 3 times 12, which is 36 inches, over 1 times 1, which is 1, or just 36 inches. Does that make sense? So I'm just doing conversions. Okay? Now, when we're converting from degrees to radians and radians to degrees, we are using one of these conversions, either 180 over pi or pi over 180. So we have to make a decision. I'm going to start with A, and I'm going to put it over 1 to make it into a fraction. What units do I have on top?
Pi. Wait. Yes.
What's this right here? That's a degree. So if I have degrees on top, I want to have degrees on bottom, right? So that they cancel. So I'm going to use pi over 180 so that the degrees on the top can cancel with the degrees on the bottom. Does that make sense? And then I just reduce. Isaac, are you following us?
Yeah.
Okay, I just reduce. So let's cancel a 0 off, right? Negative 3 over 18 can reduce. So this would be negative 1 and 6. Okay, then multiply. Negative pi over 6. Make sense? Don't put it as a fraction. Or don't put it as a decimal, I mean. Leave it as a fraction. So pi over 6, yes, you can do it in your calculator and get an answer, but no decimals at all.
Oh.
There will be no decimals at all in this section. No decimals. All fractions. Good? Okay, next. All right, so if we're going from 5 pi over 5 pi over 2, I'm going from a radian to a degree. What's my units on top?
180 degrees on top.
Yeah, I want to make sure the pi is on the bottom, so I'm going to put 180 degrees on top. So, very first thing that happens is the pi's are going to cancel, and then I start to reduce. The only number that I can reduce is 2.
180.
So 2 can become a 1, and 180 can become 90. And then what do you multiply together? 90 and 5, which is 450 degrees. Over 1 or just 450 degrees. What happens if this would have been negative 5 pi over 12?
Negative 5.
It would be negative 450 degrees. It does not change anything. It just makes the final answer negative. Right?
Yep.
Happy with that? Okay. Now, one more thing that I'm gonna discuss from your homework assignment. We're not gonna do anything else on the bottom. We're not doing example 5. Go back. 450 degrees. Yep. So go to your homework assignment. That's the end of the notes. We're not gonna do any more than that. But go to your homework assignment. I'll tell you which ones I want you to do. Ready? Here we go. There's a lot of these. Okay, do all of them on skills practice. You should have the top 10 done. Do 11 through 22. You're just converting.
Oh, you quit.
Yeah?
Oh, I already broke overdose on that accident.
Oh, man. Attach a separate sheet of paper. Rewrite them. It's fine.
Do we do any on the other side?
Okay, on the other side.
So we're doing the whole page.
Yes, all on skills practice. Yep. Okay. Mackenzie, on practice side, you should have done 1 through 9 all. You're just getting this paper, but yeah, 1 through 9 all from yesterday. And then starting with number 10 through 21, you're just doing the odds.
Wait, what?
So it'd be 11 through 21 odds, or 10 through 21 odds. So you can cross off 10, 12, 14, 16, 18, blah, blah, blah.
So
You can cancel those off. Odds. Okay? Now let's do 11 together. Because we didn't really talk about this, but it's just putting the two concepts together. Number 11, the instructions say find a positive and a negative coterminal angle. Positive, negative. 11 is in radians. 5 pi over 6. This is in radians.
So we have to.
So we have to convert it to degrees first before we find the positive negative angle, right? So, times 180 over pi or pi over 180? Which one?
180 over pi.
180 over pi, because I need the pi's to cancel. Pi and pi. Okay, then let's reduce. 6 and 8 and 180 can become 1 and 30. So 5 and 30 is 150 degrees. Okay, now I need to find my coterminal angle. So I need a positive one over here, and I need a negative one over here. How do I find the positive one? Add 360. So 150 plus the 360 is, I don't know, 510 degrees. Is that right? Okay, how do I find the negative one? Subtract the 360. Is, what'd you get? Negative 210. That's my negative angle. So, it's exactly what we were doing yesterday, but with one extra step, you have to transfer it from radians to degrees.
Makes sense.
Yes? Happy with that? Okay, that's all. Okay, get started. There's a lot of problems, but they do move pretty quick. Like, you can get them all done, I'm sure, if you work. Okay? Goodbye, people in the video. Or Michael. I think it's just Michael. Goodbye, Michael.